Welcome back, all of you. So on the last video, we talked about recursive functions and why there is a max stack limit or a stack limit here, and you cannot do more than 256. So if you try to do 255, it doesn't work, but if you try to do 254, it works. So that was recursive functions. You can go to the previous video if you missed it, so you can catch what I'm saying. So now, from the book, now we have the sum-tailed recursive function, which is the next explanation. I'm gonna take that now, which is this one, copy, and I'm gonna paste it here and run it. This will again be 6. But now the difference here, we have the sum tail. Let me, hold on, because I cannot see that much. Okay. Sweet. So now this is sum tail function. It accepts 2 different parameters, not just one. The last one that we saw, should I put it here? Oh, I think it's here. Yeah. So the last one that we saw, it's only one parameter, the number parameter. And we were just sending this, like just one number over and over again. In this case, we have the number parameter and the result parameter, which are 2 different things. And this result parameter has a default value of 0. This means that you don't have to add it when you call the function. This can be like this, or this can be like this, and it's the same thing because it's a default value that it has. So I'm calling this, and it comes to the condition. In the previous one, we had the same condition, and if the number was more than 0, then we would call the same function again, and then we would add the current number to the result of that function. If this is 0, then it will return 0. Now here, this is different. Here, we're not returning 0 here, first of all. Second of all, we are not adding the number right here, like before calling the function. We are adding the number inside the call of the function. So when we are doing this, in the previous one, we were subtracting the number 1, like 1 minus the number, or number minus the 1. So we could call, like, for example, this is 3, and then 2, and then 1, and then 0, 4 calls. And now here, what we're doing is still doing number minus 1 for the number parameter, but then on the second parameter, we are actually adding the result. So the result will be 0 at first, and then will be 0 plus the number, so 0 plus 3, and so on. So now the second time that it comes here, now the number will be 2, and now we end up here, so 2 minus 1 will be 1, and it goes on, same 4 calls, 3, 2, 1, 0, but the result will be 0 plus 3, and then 3 plus 2, and so on, right? Until you get the result. So now when the number reaches 0, you will give back the result instead of giving back a 0. So yeah, very good explanation and whatever, but let's see the diagram. So remember, if you didn't see the previous video, please go so you can compare these diagrams. But then here we have still 4 calls, right? I told you 4 calls, 1, 2, 3, 4. But now here we have number equals 3 and result equals 0, because this is first call. Sum tail 3. And it checks 3 is more than 0, yes. So sum tail 2 and 3. Because it's number minus 1, we end up with 2. And then result plus number, so 0 plus 3, we end up with 3. So then it calls the second call. Now sum tail 2 and 3. Now this was just 3, right? It's basically 3 and 0. So here we can see number is 2, result is 3. Is 2 more than 0? Yes. So now sum tail, again we said number minus 1, so we end up with 1, and result, which is 3, plus number, which is 2, we end up with 5. So now we go to the third call. Now sum tail 1, 5, number is 1, result is 5, 1 is more than 0, yes. And now we have sum tail, number minus 1, 1 minus 1, is 0. And result plus number, 5 plus 1 is 6. So we end up with 6. Now we call that, last call, sum tail 0, 6, number is 0, result is 6. 0 is more than 0, no. So this returns 6, and that's the result. We don't have to go back the way we did in the previous one, right? And now if we take a look at the text representation, remember the one that I showed you in the previous video that it looked like an arrow or a pyramid or a tree, however you want to look at it. This doesn't look like that. This is just lineal. It's sum tail 3. This could be 3 or 3, 0. And then 2, 3, 1, 5, 0, 6. And the end result is 6. 4 calls, still 4 calls, but now we don't have to go back. In the other one, we had the 4 calls plus the other 3 that went back and so on. So if I put here the log, you will still see 4 calls. 3, 2, 1, 0. So then why? Why is it not getting a limit if it's still 4 calls? Because, as I told you, the tree still keeps growing. So if I put 255, it's gonna do 256 calls. And it keeps growing. Like it just stands there, like it doesn't finish running, it's just there in the thread. And in this case, if I do 255, it's gonna work because it's doing 255 calls, but not at the same time. It's not blocking the thread. Like you did one and then you did the second one, but the first one already finished. It's not waiting for anything else. And then you do the third one and the second one already finished. So it's like just one call over and over again. And when you do just recursive functions, you have the first call and then call the second one and then the third one and then the fourth one. But then when the fourth one finishes, it goes back to the third, then to the second, then to the first. Like it goes down and it goes up. So it's not finished. And in this case, it goes down and that's it. It finishes. So that's the difference. Now I can count as much as I want and it will give me the result because it's not waiting for anything, it's just running it because the result is right there. And in the other one, the result is waiting for all of the other functions to finish running and then it will do the addition. So that is the difference. I think that was all from the chapter, right? Yeah. So that is a huge difference of why using recursive functions is better than using tail. Why using tail recursive functions is better than using recursive functions. And that's it. And you can go to the GitHub repo, as I had said, Fact Publishing, MuleSoft for Salesforce developers, and then chapter 6, section 2. You can just scroll down and you will start seeing here the README, or you can just search for the specific function file that you want and you will find it there. I'm taking them from the README because it's just easier. They're there. So you can check it out. Here's the sum recursive function. And here's the sum tail recursive function. So you can check them out, both of them, and compare them and see what are the differences. And if you buy the book, you will get the whole explanation that I just did, but I mean, it's written. Some people prefer to see things written. Some people prefer to see video or images. That's why I did diagrams, or text. That's what I did text. Whatever you prefer to do. It's your your situation, you know what to do, you know how you learn best. And that's it. I hope this was helpful. I end up rambling a lot sometimes, but I hope this helps you understand the difference between the recursive and the tail recursive functions. Let me know in the comments below if this was helpful or not. If you have any other resources that you have been reading or watching or whatever, let me know what else you want me to teach you. And go buy the book. Let me show you the cover. Oh, it doesn't have the actual cover. Anyway, MuleSoft for Salesforce developers. I will leave the link to Amazon.com in the description of the video if you want it. If not, I don't really mind. And here's the information for you to consume. Thank you so much for watching, and I will see you in the next video. Bye.